Hello, welcome to Power Up Your Anchors, and well, it's going to be not as flashy as a presentation for the vid. It's not going to be ARChy, it's not going to be ML, but instead it's going to be a very old pattern. So, let's start with who I am. I'm Pedro Carrasco, in case you don't know me, and I work at Farfetch. I'm an iOS engineer there. And during my free time, I'm also an organizer of CocoaHeads Porto and a part of organization from Swift Aveiro. Also, during my free time, I usually try to post some projects on GitHub. They are not as much as I would like to because, you start a project, it's private, you develop, you design, but then you never end it, never it's public. And that's the cycle here. I only have like 5 projects there. I also have Twitter, the same name. And I try to post the related things to iOS. And also, most recently, I usually post some blog posts that I publish on my website. I decided to revamp it. It was like a portfolio before July, but in July I decided, oh well, I want to be like Sandel and have a lot of posts and earn money from that. So that was the goal. I'm trying to be rich just by posts and nothing else. Moving forward, and this failed. So, what's this all about? It's not ARChy, it's not core ML, but instead, it's why you should power up your anchors. So you might be asking, what are anchors? Apple in iOS 9 introduced an S-Layout Anchor, the tool you probably use to develop auto layouts, to develop views, to develop some kind of design that you apply to your elements. And in this specific talk, we're going to say, why should power up your anchors? What are common pitfalls? The mythical storyboards versus zip versus code. Spoiler, I'm going to go with code because it's what this presentation is about. And we'll just reflect on whether you should use some techniques or not. And next, you have the how. How are you going to power up your anchors? How you should do it, and how are the many ways that you can do it, or which are. So, the mythical war. Storyboards, zips, or code. Keep in mind that when I mention storyboards, I'm just focusing on storyboards that contain flow. That kind of mess you usually see, that it is like, I'm taking care of these ones. When it comes to zips, it's just a single view without flows, And when it comes to code, it's just pure code. Or either Swift or Objective-C. So, source control. When it comes to source control, storyboards aren't that good. There are many ways to make them good, or at least tolerable, but from the start, we'll probably have some problems with them. Because in a big team, and it's not that hard to get some problems with, you'll probably have a lot of people working the same storyboard, even if you try to multiply and create multiple storyboards, it's a pain. When it comes to zips, source control isn't that good also. It's better because you isolate the views, so it's easy to divide across your team. But still, it's just not that good because you are looking at the conflict that you have, and you are not looking at Swift that you know. You are not looking at Objective-C that you know. Instead, you are looking at a new DSL, either Zips, Neeps, SysML, whatever you want to call it. But it's not the language that you are used to, and with that, it's not the language that you are properly able to review and decide whether or not should I take this path in the conflict or should I take the other. And that's when storyboards and zips kind of take the other side when it comes to source control. But code instead, it's a lot better than that. Your code is in Swift, your code is in Objective-C. It's something you know and it's something you have been working for a lot of time. So you can just look at the conflict and you will see, oh, this is going to do this and this is going to do that. I want to choose this or that. It's that simple. When it comes to pull requests, storyboards are not that good. Again, it's really easy to get merge conflicts. It's really easy to just get a single thing just because you opened your storyboard. Zips follow the same pattern, even though they work in a lower scale, because, well, it's not a neat container or a zip container, it's just a single zip. But when it comes to code, a pull request is easy to review. You are looking at code that you know. You can just evaluate the code from a pull request and see, is this good, is this bad, how many constraints is he using? Are these enough? Are they not enough? Is this performance? Because when you do too much constraints, it will affect your performance. The least amount of constraints that you have to do, the better. But still, you have to keep following some designs, and to do that, you probably have to apply some relations like greater or less than equal to, and things like that. But when it comes to zips and storyboards, it's just another DSL that we're not used to. It's not Swift and it's not Objective-C. So this is why they are rated as not that good when it comes to that. When it comes to dependency injection, storyboards kind of work. You can do property-based dependency injection. You can have some tools like swing inject and frameworks like that that can help you doing it. But still, you are not really able to do pure dependency injection, plain and simple. You're not able to really use an initializer to do that. Instead, you just have to cast your destination to controller and things like that. It's just not pure. You have to expose your properties to inject them, or expose your functions that you probably didn't want to expose. When it comes to zips, things get better. You control the flow, and you flow through it as you want. You can have coordinators, you can have any kind of architecture that allows you to do that. You can have routers, whatever you want to call it. There are many names for everything we do, and most of them are different, but they do pretty much the same. And this case is exactly that. You can just do dependency injection in the easy way. And with code, it's exactly the same thing. Because instead of using, because you are just doing layouts in a different way, but when it comes to dependency injection, it's pretty much just the same. When it comes to line of code, well, storyboards are kind of hero here. Storyboards, you are able to do an elbow roll app without doing a single line of code, and you can probably even do an elbow roll app with an action that moves to another screen without a single line of code. And that's really powerful, and that's where they shine and why Apple tries to push that to beginners as much as possible. When it comes to zips, they're also better than code at least, because you don't have to write your code. You don't have to, you have to write your code, you don't have to write your constraints, your layouts, your hierarchy. It's just done there. You look at it, it's visual, it's pure, you don't touch anything. It's there, you never see it again, probably. And that's why they are so good. And code's just plain code. You write it, you will see every single time, even though you can wrap it around some other object to extract it from your main view, but it will be there, and you have to write it. So lines of code are increased. When it comes to visual, well, storyboards and zips are that. They are visual. You build something, you see the immediate effect. And that's why they are so powerful when it comes to showing stuff, doing prototypes, just verify something's being done correctly in a fast way, because we don't have auto reload. We have, but it's a tricky thing. And so code really isn't that good for that, because it's just numbers. You can see numbers, letters, and a point maybe, but won't be seeing views develop in front of your eyes. So yeah, code is just that not good when it comes to visual. But trust me, if you developed auto layout via code for like a week, you'll be able to just watch the constraints and visualize internally what they are doing. It's not that hard. It's pretty simple, actually. I love to code. And you probably also love to code. If you don't love to code, you do it for the job. If you don't do it for the job, you do it for the money. But the truth is, I'm lazy. You probably are lazy because nobody wants to write code. We are coders, but every single time we try to write the less amount of code possible. Why? Because that's the way it is. The less code I write, the less bugs my app will have. Because, come on, the computer isn't going to fail. It's my code that is going to fail. And with that, I actually think that I'm lazy in a good way, because I try to abstract things when it's needed, and when it's not, I keep them simple. But I have to also think about maintainability and scalability. For example, I have a dependency that my view control is using, and at the moment, it's just one dependency. So it's going to be easy, I just inject manually. It's fine, okay, perfect. But next time my PM just calls me, hey, I want that hello world application to do cache, core data, network, and do some other random stuff with music. And then I'm messed. I have to inject 5 different things. Why didn't I build a dependency container right at the start? Because I was lazy. But you have to be lazy in a good way. And that's what I try to be, at least, or I hope so. And this is why lazy people have built things. Because auto layout in code is really code heavy. You have to write a lot. There are really tiny flags that you have to set to false. There are tiny details that you have to care. And these frameworks just take care of it. You have the famous SnapKit that's like 8,000 stars. It's a lot. You have tiny constraints that is like rising a lot in popularity lately. You have cartography, you have pure layout, you have Stevia, you have easy peasy. And even then, you have one that is better than them all. You have an incredible and a masterpiece, a 10 out of 10 framework that I built for auto layout. And take this as a joke because it's not better than them, it's just a different approach to the same problem that everyone faces. It's not a joke that it exists, and if I would see that after this talk, I'd be proud, even if you like or dislike. But it was built for the same needs that the previous one did, but with one condition. I wanted to build something for my needs, something that was built as I like or as I would like to see my code when it comes to auto layout. And this is why we are here. Because you know that, what? Screw that! You don't need to use a framework because it's famous or because everybody's using. Because that carries some upside downs. It's not everything perfect. SnapKit was built like some years ago, it's really famous, but it may not fit your case. It's probably not be the best approach to your problem, because they carry problems. They are an external dependency, and you know, there are a lot of companies that are really rigid when it comes to, should you add this external dependency, is that the way? And they have to go through an approval process to get it added to your application. And when that doesn't happen, you also have to think, this is external. Do I want to keep this? What if this gets archived? What will I do? And even then, when you get that answer, it's a new DSL, it's a new interface. You'll get people to apply to your team, to try to join your team, you'll accept them. You'll have a lot of business logic to teach them. You'll have a lot of architecture to teach them. You have your network, your router, your everything you want, name it. And you'll have also an interface to show them when it comes to auto layout. Because you are not using the one that Apple provided you, you are using a framework for that. And most of the times, these frameworks really carry a different syntax, DSL and interface, regarding that. And that will just add a bigger learning curve to your project. People will take longer to give value to your team, to increase the value of your project, and they will probably be kind of not really satisfied with some things, because imagine that I work with SnapKit in a team. I will probably learn and be master of SnapKit, but then I will go to another company, and they use tiny constraints, and suddenly all my knowledge that comes with SnapKit is lost. I mean, I still have the fundamentals of building layouts and how things work, but I have to waste my time learning a new syntax, learning a new interface, and that can be good, but it can also be bad, depending on your case. Because sometimes it's overkill. Your project can be fully zips, and I have only like one view with code, and you'll be adding one dependency for one view. You'll be adding like 500 lines of code to reduce 3 lines of code that you have to write. Is that worth it? I don't think so. So let's go back a little and see what April gave us. So, this is probably almost older than me. They gave us bounds, frames, and masks, you know, that dot flexible width, dot flexible length, and things like that. Then they decided, oh, let's build a model layout. And they built an layout constraint, which initializer was a mess, and the visual syntax, it's kind of a mess. And they were like, oh, it's iOS 9, we'll give you an layout anchor, which is like so fresh and so good. And so beautiful. It's amazing. You have to set this thing to false in every single view that you want to use. And that's not really restricted to an layout anchor, but to the auto layout system. When it comes to the anchor itself, you have to set it active every single time. You can avoid that. You can do ns layout constraint.activate and set an array of constraints that come from these anchors. But then we'll add like this indentation to your code. For what? Because they are not active by default, is that worth it? And then In your interface builder, you can add priorities to your constraints, because you might need them. But here, you want to use them, you have to waste 3 lines of code to do that. You have to pick your anchor, apply to a constant or to another anchor, set it as a property, set its priority, and if you want a priority that is not the same as the default one, that is fit size level, default low, default idle, and required, you have to do a messy initializer, and then you have to set it to is active, which is true again. And then, just look at the pattern. We have like 3 different types of functions when it comes to relations. You have equal, you have greater, and you have less. But what does this look like? It looks like an enumeration. And the fact is, they have an enumeration for this. It's called an S-layout relation. Actually, with iOS, with Swift 4.2, it's called an S-layout constraint dot relation. But why didn't they use it? Okay, I'm okay they use that because, well, it's using Objective-C and Swift. They have to take care of the interop, and that was probably the biggest reason for them because in Objective-C with none, it wouldn't look that good. But still, since we are aiming for Swift, let's try to build something that's more Swift-headed. So let's see if I didn't miss anything. This one, I won't even dare to say its name. You know, you have to set it to false to every single view that you want to apply a layout. They're not activated. It's a mess. You have to do that to every single anchor. Actually, to every single constraint. Or you can avoid that with the NSL constraint dot activate. You have priorities. You have to write 3 lines for the price of 1. Okay, you can do dot comma between every line and that will be 1, but that doesn't work for me. And it's more biased on the personal taste. You have to write 1 function for every relation. You can just try to follow a more Swift way to do this with an enumeration-based approach. And that's what we are going to do. We'll try to build not a framework. I mean, it can be a framework, but not a new DSL, not something that people join your team and don't understand or not carry knowledge. Instead, you'll be using the same knowledge that Apple gave you, anchors, and improve it. Improve its interface, give you some power that you are not able to do with that, or at least reduce the amount of code that you have to write to do that. And with that, we'll try to use some of the Swift capabilities that were introduced, like default parameters, variety parameters, and even discardable result that's not fully exclusive to Swift, but it's something kind of new. So yeah, this is the time for a small workshop. Any questions for now? No? Is anyone mad because I choose code? I hope not. So, where is our anchors? Next. So, how is the font? Is it big enough? Okay. What about the colors? Did I change anything? It's okay. So, this is an example. Don't try to do these constraints, they won't work because they don't make no sense. Instead, I'm just trying to showcase the many possibilities that you can do with anchors. You can do constraints between 2 anchors with a constant. You can do without constants. You can do strictly to a constant and not to an anchor. You can do with relations. You can set priorities. And you have this big thing. That's called translate or resizing mask into constraints. So, to start things off, what is an S-layout anchor? And to show that, I think the best way is Apple docs. Even if I write this, it will be enough. Yeah, it is. As you can see, I've seen that because I have to double check things. So, when it comes to an S-layout anchor, it is kind of a father to the anchor system, which is a generic class that is adopted by 3 children. That is an S-layout x-axis, an S-layout y-axis, and an S-layout dimension. These are for, you know what? It's leading, trailing, right, left. Here you have for bottom, top, and center Y. You have for the next dimension for width and height. And these are the main powerhouse of your anchor system because you cannot apply constraints between an S layout anchor. Instead, you have to apply constraints between this guy, and this guy. And this is where Apple tried to improve their system because with an S layout constraint, you could just apply a constraint between an S layout x-axis and an S layout dimension. You could try to apply a leading with a width anchor, but then that would crash or it wouldn't work as true because it's not supposed to work. And this is where Apple tried to shine and improve their interface. They built an S layout anchor with a type checking interface that tries to match anchors. That means you can only constrain anchors between an S layout x-axis to another an S layout x-axis and an S layout dimension to another S layout dimension, or in this case, you can also constrain to a value of a CG float. It's kind of special because it's a dimension. So, what are we going to do now? This will kind of break in two parts. First, we'll try to solve the translate autoresizing mask issue because that's not really associated to the anchor system, but instead it's associated to the auto layout system. And then we'll try to tackle the problems with an S layout anchor and its childs, the S layout dimension, axis in X, and the other axes. So, to start things off, I have just these constraints here so we can try to see what we have to chase and what we have to tackle. So, we could build this in a framework, but to keep things simple, we'll build this in one single file. Lately, in your home or after this, you can just split in multiple files. That would be what I would do. I don't like to keep files big, but for the sake of having all in the same file and keeping it simple, this is going to be all in one. So I'm going to just create a file called anchor. That is going to be the main powerhouse, and I'm just going to import UIKit now. So, first thing, we don't like that. Having to do this, no matter the amount of views you add here, is not that going to work. It's not beautiful. And trust me, forgetting this happens. And when it happens, your views will be laid out as they shouldn't. And you'll waste hours of your life looking at your code and trying to understand why are not they laid out as they should. And then you'll just look at your constraints, modify things, and they won't work anyways. Because then you will see, oh, I forgot a thing. And you'll just do this. You'll look, translate, escape, enter, false. Because it's the way it is. It makes no sense for us to have to do this every single time when we live in a world that is mostly based in the auto layout system. It's not based in the frames, bounds, and mask systems anymore. Most of the things we'll be doing is auto layout because that's the way Apple is trying to push us. Even though there are defenders that defend that the auto layout system performance it's kind of worse than the traditional ways with bounds and frames, and performance metrics I think that also verify that. But the drop between the complexity of your code and the lines of code that you have to write when compared to that, at least to Apple, justifies pushing through the new auto layout system. So let's start with the view. To do this, we'll extend the view. And if you take a look at what we are doing here, there are multiple ways of doing this, so keep your mind open, and if you have another opinion, feel free to share. What we are doing here? We are picking an array of views, and for each one we are adding them a subview, and then we set it to translate autoresizing mask constraints to false. So, one option would be like doing a function for that, where we could just send an array of views that returns nothing, and then you just do views, and for each one you do self, oh, that's here, this one, and then you just do that messy thing of doing this. And yeah, this is one solution. Depending on your project, and if you use frames, bounds, and stuff like that or not, it can be a tricky or hacky solution, because if you do that, you are adding a side effect to your function regarding asset views, and with that you can just hide this implementation, and people that actually want to use frames and bounds will have problems because they'll be using this and it will work for them. They'll kind of suffer what we suffer when we forget to set this to false, so it's kind of a trade. But if you want to do another approach, you can just do heads of views using auto layout if you want to make it more implicit, or you can even have just a function that's just prepared for auto layout, where it's an array of views. But for a matter of simplicity, we'll just call heads of views for this one. I'll just create a simple function to display our progress. So we were doing this, and now instead, and according to our function, we could do just this. But you know what? This looks better than that, at least to me, even though it has a side effect, but you can manage that and find ways to explicitly say that. But it can be improved, because Swift offered an approach that allows us to be even more verbose or even more cleaner. We can just add a variety parameter. It just works like an array, but instead of having to set as an array, I can just separate it from the commas. Inside our function, it is treated as it was an array. Like you see, you can do for each, you can loop, it's a collection, and in fact, it is an array. What is the main drawback from variety parameters? You can only have one per function, and that's sad, very sad. But yeah, they are powerful, and the truth is, if you add more things, for example, 2, and add all that, this will be a mess. So I'm okay with Apple limiting that to 1. And in this scenario, it works. It fits. It's beautiful when compared to this. So now, what can we do? Like, it's working good now. Just that, and we keep this. No, it's not going to happen. We have to remove that as active at least. So to start off, let's extend and let's lay our anchor, because that's the father, that's the godfather of the anchor system.